Hello everyone, and welcome to your video on the degrees of polynomials. So the first thing that we want to be able to do after watching this video is to classify polynomials. Now I think this is pretty straightforward, so I'm just going to give you a couple examples and then we'll see how you do. So let's say that we had this. We had 3x squared plus 1. How many terms is that? Well, that's two terms, right? We have this term being added to this term. Okay, let's do another one. What if we had 7x plus 4y plus 3m? How many terms is that? Well, that would be 3 terms. This one, and this one. Okay, let's do one with bigger numbers. 15x to the third plus 29x to the fourth plus 33x plus 81. That is 4 terms. Are you getting this? This. This is pretty straightforward, isn't it? How about this one? 12p to the fifth. How many terms? 1 term. Okay, so what we have here are all these different polynomials. Poly just means more than one. More than one. So all of these are different types of polynomials. They do have more specialized names, however. A 2-term polynomial is more precisely known as a binomial. Just like your bicycle has 2 wheels, a binomial has 2 terms. A 3-term polynomial could more precisely be called a trinomial. Again, a tricycle has 3 wheels. Once we get to 4 terms, though, we usually just start calling them polynomials. And we don't have quadnomials and septnomials and stuff like that. No, we just go, we do bi, tri, and poly. And oh yeah, we do have a special name for the one monomial. For the 1-term polynomial, which is simply a monomial. So monomial, binomial, trinomial, and polynomial. But all of these, well, not the monomial, all of these are types of polynomials. Okay, does that make sense? I hope that makes sense. All right, now I would like to point something out before we move on to the next thing. Let's say that we have this polynomial. We have 15x to the third, p to the 7th, plus 21x to the 4th, p to the 8th. This is a binomial. And so notice that it doesn't matter how many terms are in each term, or I should say this, it doesn't matter how many variables are in each term for it to be a term. As long as these things are being multiplied together, they work as one unit called a term. Okay? So each set of things multiplied all together equals a term. Okay? So each set of things being multiplied together equals a term. Now, I will give you some exceptions to polynomials. These are common, tricky questions. So let's say we have this, 4x to the negative 2 plus 3. Guess what? This is not a polynomial. What? You're saying? It sure looks like a binomial to me. Yeah, but there's a fancy-dancy rule that says that in order to be a polynomial of any kind, all exponents must be non-negative negative integers. Non-negative integers. And here we have a negative integer, so technically this is not a polynomial. This would also not be a polynomial if I had 3x to the 1/5 plus 2x to the 8th plus 5x squared. It looks like it might be a trinomial, but it's not, because this is 1/5. This is not an integer. Even if I wrote it as 0.2, it would not be an integer. So these have to be like normal numbers up here. They can be 0, because 0 is still a non-negative integer. So 0 is okay, but funky numbers like fractions and negative numbers, not okay. All right, so that's the first thing that you need to be able to do, is you need to be able to classify these polynomials based on how many terms are being added and subtracted. Okay, the second thing that you need to be able to do is to write polynomials according to descending powers. So let me give you an example of what I mean. If we have x to the 3rd plus 5x squared plus 6x to the 8th, this is a polynomial, but this right here is considered bad form. Why? Because we should write it like this: 6x to the 8th plus x to the 3rd plus 5x squared. What's the difference between these two? Well, the difference is that here our exponents are counting down. We have 8, which is bigger than 3, which is bigger than 2. So as you move through the polynomial, your number gets smaller and smaller and smaller. Let's do another one. Let's try this one. 14x minus 22x to the 6th plus 93x to the 0 minus 5x to the 10th. You take a second and tell me what that should be written properly. Well, it should be negative 5x to the 10th minus 22x to the 6th plus 14x plus 93x to the 0. Almost ran out of room there. So notice that it doesn't matter if these coefficients here are bigger or smaller. All we care about is making sure that the x's are in the right order, okay? That's the proper way you write polynomials. And it's so accepted that if you were to leave it in this funky format, people would look at you and say, why are you writing it like that? I mean, it should be like automatic for you to write it in a descending power format. That's just the way we do things. Now, it does get a little trickier. Let me show you this. Because in the examples that we just did, we had like x to the 3rd plus 5x squared plus 6x to the 8th. This example that we just did, you'll notice that there's only one variable, right? But what if there are more than one variable? So, for instance, what if this were our equation? Negative 4x to the 3rd y squared plus 9x to the 12th y minus 5xy to the 6th. What if that were our polynomial? What order should that be in? Well, you could put it in one order according to the x's, or you could put it in a different order according to the y's. But really what we want to do is we want to put it in order of the total power. So the power here is 3 plus 2, which is 5. The power here is 12 plus 1, which is 13. And the power here is 1 plus 6, which is 7. So the correct way to write this equation would be our 13 power first, x to the 12th y, our 7th power next, minus 5xy to the 6th, and our 5th power last, minus 4x to the 3rd y squared. This would be in descending power order, which is good. So that's great. However, some of you are sitting there and thinking, yeah, but what if it doesn't work out exactly like that? And for those nitpickers out there, I'm going to give you an example. Here we go. Try this. Negative 3c squared d squared plus 5c to the 3rd d plus 7cd to the 3rd. All right, smarty pants. What do you think this is? Well, what's the power of this? That would be 4, right? 2 plus 2 is 4. What's the power of this one? 4. 3 plus 1 is 4. What's the power of this one? Still 4. 1 plus 3 is 4. So what do we do in this situation where all of our terms have the same power, but they're not the same? Yeah, good question. And here is where you get a choice. Basically, mathematicians just don't want you to approach this all willy-nilly. They want you to have some sort of approach. So you could do it in descending order of C. And if you did that, you would look at your C terms, all of your 4 terms. These all have the power of 4, so these are all technically the same level, but inside that level, we would first do this one, 5c to the 3rd d, then do this one, minus 3c squared d squared, then do this one, plus 7cd to the 3rd. So now we're counting down our c's. This is c to the 3rd, this is c squared, this is c to the 1. However, as an alternative, you could write it in descending order of d, which would be this one first, 7cd to the 3rd minus 3c squared d squared plus 5c to the 3rd d. Both of these are technically correct. You would say that this one is in descending order of C, and you would say that this one is in descending order of D. So that's how we do it when we have multiple terms that are the same total power. Okay, one more thing to learn in this video, and that is how to give the degree of a polynomial. Give the degree of a polynomial. And for this, we are going to keep life pretty easy. We're not going to come up with every possible nitpicky thing that we can. Let's say we have 6x plus 15. This has the power of 1, and this has the power of 0, right? Because this is x to the 1 and this is x to the nothing. So we would say that this polynomial is degree 1 because you picked the largest number. What if you had this? What if you had 4z squared minus 11z plus 2? Well, this is degree 2, this is degree 1, this is degree 0, so we would say that the whole polynomial is degree 2. Okay, wait, just a smidge harder. What if we did this one? 5x squared m squared minus 5x squared m to the 8th. What does that equal? Well, this is going to be degree 4, and this is going to be degree 10. So we would say that this binomial has a degree of 10. So anyway, so that's the basics of how we go about classifying polynomials. I hope that makes sense to you.